Welcome. We are going to start this lesson with a warm-up. Solving for x, as I've said many times, solving equations is extremely important. We're going to keep coming back to it over and over again. Anytime you see parentheses with a sum or a difference in it being multiplied by the same number, we can use the distributive property. So we're going to start by drawing in our line and using the distributive property to simplify this side. So 2x minus, and then 2 times 15 is 30. And on this side, we're just going to leave it 3x plus 20. Now the first thing I notice is that I have variables on both sides. So I need to collect them on one side. I personally like taking the one that is the least and moving it. So since negative 3 is less than 2, I'm going to move the negative 3 over, or the negative 3x over, by adding 3x. If you do it to one side, you have to do it to the other. So now I have 20 equals 5x minus 30. So we want to solve for x. It says minus 30, so we have to add 30 to both sides. So 20 plus 30 is 50. We are still left with this 5x. It's multiplied, so we have to divide. So x should be 10. And please remember to check your work. So now I am going to plug 10 back in, so negative 3 times 10 plus 20 should equal 2 times 10 minus 15. So that's negative 30 plus 20 is negative 10. And if we do, 2 times a negative 5, that's also negative 10. So it checks out. We know this is our answer. Okay, so I'm going to move this bigger for us because now I want to remind you of how to graph points, because it's really important that you can name points on a graph today and graph them. So I want to first remind you that when you have an ordered pair, it needs to be in parentheses. The first number is the x coordinate, the second number is the y coordinate. And what this tells us is the distance from the origin, 0. So it's like our driving directions. If you start at 0, if you start at the home base, how do you get to each of these points? So let's start with A. For A, you have to go, and again, this is the x-axis, this is the y-axis. So you have to go over 1, 2, 3, 4. So we're going over 4. Now this is like a number line. If this is 0, these are all the negative numbers, these are all the positive numbers. So we're going over negative 4. And we have to go up 1, 2. So the ordered pair that names the location of A is negative 4, 2. Let's do another one. B. Here's B. Remember, the first coordinate tells us how far we move over. The second coordinate tells us how far we move up. So 1, 2, 3. And again, we're going positive 3. And to get to B from that point, you have to go up 1, 2, 3, 4. So on the x-axis, this is going to the left is negative, going to the right is positive. Going up and down, this is like a thermometer. Going up is positive, going down is negative. All right, C. To get to C, we have to go to the right, so the x-coordinate is going to be positive, 1, 2, 3, 4, 5. But then we have to go down, so the y-coordinate is going to be negative, so negative 1. So 5, negative 1. And D, if we start at the origin, we have to go over none. So our x-coordinate is going to be 0, but we have to go down 1, 2. So it's 0, negative 2. Please remember when you're naming ordered pairs, you use parentheses with a comma in between. The x tells us how far we go to the left or right from 0. The y tells us how far we go up or down. All right, let's continue. even though we're talking about whether a graph is proportional or not and finding the unit rate today, I want to start with just a quick review about the table. Does this show proportionality? Why or why not? So justifying our answer. So there are a few different ways to do this. The first way, I know that it doesn't because when x is 0, y is not 0. So my justification could be that there is not a 0-0 relationship because when x is 0, y is not 0, and we need that 0-0 relationship. I could say there's not a common multiple. 1 times 10 is 10, but 2 times 10 is 15. Is not 15, it's 20, so there's not that common factor. The best way right now that's going to help you the most is finding the unit rate. So the unit rate. So 10 is to 1, 15 is to 2, 15 is to 2 is 7.5 is to 1, 20 is to 3 as, so all we're doing is simplifying. We know that it's not going to be the same as 10 to 1. 7.5 to 1 is not the same as 10 to 1. So the unit rates, so no, it's not proportional because the unit rates are not the same or not equal. What about this table? So this is how we're going to segue. We're going to start with a table and then look at a graph and see what a proportional relationship looks like on a graph. So first, is it proportional? Well, I see my 0-0 relationship, so that's a plus. I see that if I take my x and multiply by 3, I always get the y, so I needed that. I see that if I triple my x, the y triples as well. So yes, it is proportional. And again, the best way right now is to do the unit rates. 3 is to 1 is the same thing as 6 is to 2 is the same thing as 9 is to 3. It always equals 3 to 1. And the reason I want you to do that is I want you to get in the habit of doing that y over the x. Always y over x. So yes, all unit rates are the same. So what is that unit rate? Well, I'm multiplying by 3 so I can see it here, but I can also see once I simplify, it is 3 per 1. And the equation, remember, what did we have to do to x to get to y every time? Y equals 3 times x, where this coefficient is our rate. So what does this look like on a graph? So let's just take a moment to graph this. So I'm going to graph each. Remember, my ordered pair, x is how far we go left to right, y is up, down. So my first one is 0, 0. That's right there. Then I'm going over 1, up 3, and then over 2, up 6, and over 3, up 9. So that first ordered pair is how far we're going over, the second is how far we're going up. So what does this look like on a graph? What does it look like? Well, proportional relationships will make a line, and I want to just add that word straight because some people think that a curvy, something like this, is also a line, but we're talking a straight line. And just like we talked about yesterday with tables, it has to have that 0, 0 relationship. So here, when x is 0, y is 0. So any proportional relationship graph goes through this point right here, and that point right there is called the origin. The origin. It's where the graph is 0, 0. So let's do a few more examples. First, I want to remind you that you need to include labels. So I have the axes set up for you as far as numbering, but I want you to include labels. This first one is always the x, so the first column is always the x, the second column is always the y. And if it is going horizontally like this, the top is always the x, and the bottom is always the y. So when the hours are 1, so this is hours, and I want you to put those labels, hours and cost. The labels are really important. So when it is 1 hour, the cost is 2. When it is 2 hours, the cost is 4. When it is 3 hours, the cost is 6. When it is 4 hours, the cost is 8. And then I'm going to connect them going all the way through your coordinate plane. Does this show proportionality? Well, we could talk about it as far as the table goes. We know that it had a common multiple of 2, that all of our unit rates were the same. $2 per 1 hour. $2 per 1 hour. But I'm going to talk about it for the graph. I can justify that it is proportional. Yes, it's proportional because it formed a straight line through, and I know this is not the correct right through the, do you remember what the vocabulary word is? Origin. And we find the rate. Yes, we found the unit rate over here. We did. We found the unit rate over here, but I want to talk about the table. The rate is how much you go up and over to get to the next point. So again, it's kind of like driving directions, but instead of always from the origin, it can be from any point on the line. So it is how far we go up compared to how far we go over, or that y change over the x change. So I can pick any 2 points from here to here. I had to go up from 2 to 4, up 2 over 1, or I could have started here, up 2 over 1, or I could have started here, up 4 for every 2. So it doesn't matter what 2 points we connect, it always ends up being that same unit rate. $2 for every 1 hour. $2 per hour. So the equation is exactly like what we have been doing. Y equals our rate is the number or the coefficient in front of x. So it's easy to see on the table that what you have to do to the hours, you're multiplying by 2 every time. It's not as easy to see that on the graph, so you're going to have to remember it just fits this form. To get the y, you always have to multiply the independent variable by the rate, or 2. Okay, so what I'd like you to do is pause and try to do these next few problems on your own before starting the video again to make sure that you are understanding. So you're going to look at the graph, decide if it shows proportionality, justify why you think it does or doesn't, and then if it does, you're going to name the rate and the equation. Alright, so does this show proportionality? Well, I think it does because it is a straight line that goes through the origin. So yes, and I don't like that word it, so it's hard to not put that it, but I want to know more specifically. What are we talking about? We are talking about, so yes, because there is a straight line through the origin. So that's what you're looking for graphs. It's really easy. If it's a straight line and it has that 0, 0 relationship, so it goes through the origin, then yes, it is proportional. That simple. All right, to find the rate, just pick a point. You're going to go up 20 for every 2, or up 40 for every 4, or up 60 for every 6. So just pick a point and figure that unit rate. And remember, the unit rate is the y over the x. So if we're choosing this point right here, 60 and 6, we went up 60 for every 6, which is 10. And we're not going to just leave a 10. Remember, it is a rate. So this is in cents. So you could put 10 cents per 1 pound, or you could write it 0.1 with a dollar sign per 1 pound. I don't care which, you just need to be accurate with your labels. So since this says cents, get it, cents, this is cents, I'm going to write the equation using this way. So the equation is going to be my y, it is 10 cents for every pound, where that coefficient is my rate. The coefficient is my rate. All right, now you're kind of getting the hang of that. I want to introduce a new vocabulary word, constant of proportionality. The constant of proportionality is just that constant multiple, what we're multiplying by every time to get to our new. What are you multiplying x by to get to y? Constant of proportionality. You will see that on standardized tests. It's good to know that vocabulary, but it's also known as the rate of change, or, and this is huge for algebra, the slope. The constant of proportionality for a proportional relationship is the rate of change or the slope. So here, is this proportional? Yes, it's proportional. How do we know? Straight line through the origin. Or you could talk about that 0-0 relationship. Or you could talk about how the rate of change is always the same. 20 over 2 is the same thing as 40 over 4 is the same thing as 60 over 6. So it is 10 over 1. So 10 cents, and we just did this one, over 1 pound. So that constant of proportionality, when you're asked to find that, it's just the rate of change. And again, we just did this problem, so I hope you know that it is y equals 10x, where that rate is the coefficient of x. I hope you're pausing and figuring these out so to double check your own knowledge. So is it proportional? Yes. How do I know? Straight line through where? What's that vocabulary? Through the origin. Again, the origin is 0-0. It shows that 0-0 relationship. So rate of change, now be careful here. The rate of change is the y change over the x change. So if I start here, I had to go up 4, so there's 4 downloads for every 12 websites. The most common mistake is saying that this is 3, that the rate of change is 3. But remember, the y goes on the top. It's the y change over the x change. So I could go all the way up to this point, where it is 12 over 36. And regardless, what we simplify that to is 1/3. 4 over 12 is 1/3. 12 over 36 is 1/3. So there is 1 download for every 3 websites. That's what that number means. So every time you go to a website, every 3 websites you visit, you get 1 download. And remember, this rate, when we're writing the equation, is the coefficient of x. So y equals 1/3 x. Almost last example. Is this proportional? If so, what is the constant of proportionality? And remember, that just means the rate or the slope and the equation. Well, it is a straight line. I can see that. But does it have that 0-0 relationship? The 0-0 relationship is right here. It's at the origin. The line does not go through. So no, this is not. And my justification is the line does not go through, yes, I know I was spelling that word wrong, the origin. So if that is the case, you do not have to write the rate or the equation. All right, I think that is it for now. Make sure as you're working on your assignment, if you get stuck, you ask for help. And in the meantime, we out.